Welcome to this tutorial on conic sections-Ellipse. In this tutorial, we will learn standard equations and parts of an ellipse, to use GeoGebra to construct an ellipse. Here, I am using Ubuntu Linux operating system version 14.04, GeoGebra 5.0.388.0-D. To follow this tutorial, you should be familiar with GeoGebra interface, conic sections in geometry. For relevant tutorials, please visit our website. Ellipse. An ellipse is the locus of points whose sum of distances from two fixed points is constant. These fixed points are called the foci. Observe the center O, foci F1 and F2. Vertices A and B are at the ends of the major axis AB. Co-vertices C and D are at the ends of the minor axis CD. Two lattice recti pass through the foci. Axis lengths 2A and 2B and distance between the foci 2C are shown in the figure. Be careful to distinguish length from letters used for sliders, circles and ellipses. Let us construct an ellipse in GeoGebra. I have already opened the GeoGebra interface. Click on Point tool and click twice in Graphics view. This creates 2 points A and B, which will be the foci of our ellipse. Right-click on A and choose the rename option. In the new name field, type F1 and click OK. This will be one of our foci F1. Let us rename B as F2. Click on Slider tool and click in Graphics view. Slider dialog box appears in Graphics view. Stay with the default number selection and in the name field type K. Set min value as 0, max value as 10, increment as 0.1. Click OK. This creates a number slider named K. Slider K can be changed from 0 to 10. K will be the sum of the distances of any point on the ellipse from the foci F1 and F2. We will create another number slider named A. Its min value is 0, max value is 10, increment is 0.1. Click on Circle with Center and Radius tool and click on F1. A text box appears. In the Radius name field, type A and click OK. A circle C with center F1 and radius A appears. Drag slider A to 2 and slider K to 5. Click again on Circle with Center and Radius tool and click on F2. In the text box that appears, type K minus A and click OK. A circle D with center F2 and radius K minus A appears in Graphics view. Under Move Graphics view, click on Zoom out and in Graphics view. Click on Move Graphics view and drag Graphics view. Under Point, click on Intersect tool. Click on the two circles C and D. This creates points A and B. Under Line, click on Segment tool. Click on points F1 and A to join them. Next, click on points A and F2 to join them. Click on Move. Double-click on segment AF1. Click on Object Properties to open the Preferences dialog box. Segment AF1 is already highlighted in the left panel. Holding Ctrl key down, click and highlight segment AF2 as well. Under the Basic tab, make sure that Show Label is selected. Pull down the drop-down menu next to the Show Label checkbox. Select Name and Value. Under the Color tab, select Red. Under the Style tab, choose Dashed Line Style. Close the Preferences dialog box. Draw segments BF1 and BF2. Make them dashed and blue. Make sure that the Move tool is highlighted. Move the labels so you can see them properly. Note that the sum of the segment lengths from both foci to each intersection point is equal to K. Right-click on A and B and check Trace On option. In Algebra View, uncheck circles C and D to hide the circles. Right-click on slider A and check Animation On option. Next, right-click on slider K and check Animation On option. Note the locus of points traced by points A and B. These traced points are all equidistant from points F1 and F2, the foci. They lie on ellipses for which points F1 and F2 are foci. Right-click on sliders A and K and uncheck Animation On option. Drag sliders A and K to different values to see more traces of ellipses. Set slider K between 9 and 10 and slider A between 5 and 6. Note that for a given value of K, as A changes, lengths of segments AF1 and AF2 change, but their sum remains equal to the value of K. Note the same fact for segments BF1 and BF2. Click in and move Graphics View slightly to erase the trace points. Click on Move tool and move points F1 and F2 to different positions in Graphics View. Values can be changed on sliders A and K to see various ellipses. Let us look at the equations of ellipses in a new GeoGebra window. In the input bar, type the following line describing the sum of two fractions equal to 1. To type the caret symbol, hold Shift key down and press 6. For the first fraction, type the numerator as x minus h in parenthesis caret 2. Then type division slash. Now type the denominator of the first fraction as a caret 2 followed by plus. For the second fraction, type the numerator as y minus k in parenthesis caret 2. Then type division slash. Now type the denominator of the second fraction as b caret 2 followed by equal sign 1. Press enter. A pop-up window asks if you want to create sliders for A, B, H and K. Click on Create Sliders. This creates number sliders for H, A, K and B. By default, they go from -5 to 5 and are set at 1. You can double-click on the sliders to see their properties. A circle C, a special case of an ellipse, appears in graphics view. Center H, K is at 1, 1 and radius is 1 unit. In algebra view, note the equation for circle C. Drag the boundary to see it properly. Under Move Graphics view, click on Zoom Out tool and in Graphics view. Click on Move Graphics view and drag Graphics view. Keep track of the equations in Algebra view as you change A and B on the sliders. Place the cursor on equation C in Algebra view. A is associated with the x minus h squared component of the equation. Observe how A controls the horizontal axis of the ellipse. Associated with the y minus k squared component is B. Observe how B controls the vertical axis of the ellipse. Drag slider A to 2 and B to 1. When A is greater than B, the major axis of the ellipse is horizontal. Note the equation of the ellipse. In the input bar, type focus C in parenthesis and press enter. Two foci, A and B, are mapped in graphics view and their coordinates appear in algebra view. In the input bar, type center C in parenthesis and press enter. Center C appears in graphics view and its coordinates appear in algebra view. In the input bar, type vertex C in parenthesis and press enter. Vertices D and E appear at the ends of the major axis. Co-vertices F and G appear at the ends of the minor axis. Under slider, click on Text tool and click in Graphics view. A text box opens up. In the Edit field, type the following text. Press enter after each line to go to the next line. Click OK. Refer to additional material provided with this tutorial for these calculations. Leave slider A at 2, drag slider B to 3. Note the effects on the shape of ellipse C and the change in directions of major and minor axes. Note also the change in the equation in algebra view. Drag the boundary to see it properly. Calculate eccentricity and length of latus recti, major and minor axis for this ellipse. In algebra view, uncheck ellipse C and all points and text generated for it to hide them. Follow the earlier steps to construct ellipse D for these two conditions. Let us summarize. In this tutorial, we have learnt how to use GeoGebra to construct an ellipse, look at standard equations and parts of an ellipse. As an assignment, construct ellipses with the following foci and vertices. Find all these values. Find all these values for these ellipses. The video at the following link summarizes the spoken tutorial project. Please download and watch it. The Spoken Tutorial Project team conducts workshops and gives certificates. For more details, please write to us. Please post your timed queries on this forum. Spoken Tutorial project is funded by NMEICT, MHRD, Government of India. More information on this mission is available at this link. This is Vidya Iyer from IIT Bombay signing off. Thank you for joining.